So for this laboratory practice, what I'm going to do is I'm going to take two samples of steel, a 1018 and a 1045 steel, and I'm going to do all the mechanical tests for both of those steels, so I can see the results of both steels, see if they are as I expected or not, normal or not, and compare both of them so I can see, especially the difference between both of them is the percent of carbon present, so I can see how that affects the behavior of a material. So this is the first step for this laboratory practice. After you have colored all your steels, it's not, the size is complicated to work with, so we come to these machines where we will cover them with bakelite, so we can mold them and do everything we want to actually work with those pieces. And after we have molded with bakelite, the pieces are opaque, so you will not be able to see them clearly on the microscope. So then you come to these greener and polisher machines, so you can get a shiny face to those pieces. Afterwards, you will do the chemical attack, and finally, this is all to make able to look our pieces in the microscope. So this is an image taken from the microscope of the steel 1018, and it was using a 1000 magnification lens, and we were able to count 12 grains, and then we did all the ASTM procedure to calculate the grain size, and I got 11 ASTM size. This picture is from the 1045 steel. As it looks, it is more crowded than the 1018. Again, using a 1000 magnification lens. On this image, I was able to count 15 grains. And again, I did all the procedure of the ASTM grain size, and I was able to get 12 ASTM grain size. Now this is the universal machine. We will use it to do the tensile test of the steels. What we do is that we have a tube with the ASTM size. We'll place it here in between the two jaws. This is the fixed jaw and this is the movable jaw. And what they do is that they pull the tube very slowly, and they will get a stress against strain graph, so we can find out from this machine many mechanical properties of the steels. So here are the results of the tensile test. The graph to the left is the graph of the 1018 steel, and the graph to the right is for the 1045 steel, and below is a comparison table between the both steels. And one thing that I think is quite weird is if you see the 1018 strength and strain graph, you can see that after the elastic region, the stress decreases as the strain gets larger, and I think that's because the area on the steel 18, as you can see, get reduced quite a lot, 65%, and the graph of the 1045 steel is basically a normal graph, and I was able to get all the mechanical properties for both steels normally. Now this is the hardness test machines. The first one is Vickers that measures it in a microscopic way. It will apply a load of 300 grams, and the denter is in the shape of a diamond. Then these two machines are Rockwell. The denter is in the shape of a pyramid, and it will apply a load of 150 kilograms, and these needles will show you the results of the hardness. And finally, the Brinell hardness test. This denter is in the shape of a sphere, and it will apply a load of 3 tons. This is the results table for the hardness test for both steels. And this could be expected. The 1045 steel, as it has more carbon, it should be harder, and the results show that it is harder using the 3 methods: Vickers, Rockwell, and Brinell. This was a result exactly expected as it is. Now this is the pendulum for our impact test. In this case, we will do a sharpening impact test. What we do is that we place the pendulum here, our piece in the bottom, and let the pendulum drop, and it will give us a reading of how much energy it absorbed before breaking. We will do this test 2 times, one at room temperature and the second one cold, taken from the refrigerator, so we can see how the temperature affects the energy absorption. Finally, this is the results table of the impact test for both steels. The first 2 rows of the results table were done with pieces taken from the in refrigerator, as it can be seen, it was taken at minus 14 degrees Celsius, and it was quite a low energy absorption, and below 10% brittle factor. Then at room temperature, the energy absorption increased significantly, and then the steel 1018 presented a ductile fracture as opposed to the 1045 presenting a brittle fracture. In this case, the 1018 still resulted to absorb more energy than the 1045, probably because it has less carbon. What I can conclude from this laboratory practice is first, it was quite long because normally we take each test by team, but this time I had to do all of the tests, so it was quite long. And then some of the results were unexpected. For example, on the tensile test for the 1018 steel, the results graph were quite weird for the steel. Now that I got some results that I didn't know they will happen, especially in the impact test. I didn't know if the 1045 or the 1018 which will absorb more energy. Um, I also found that both of the steels they have their advantages and their disadvantages for the application they can be used. And as it can be seen, that small difference in the percent of carbon does make a huge difference on the results. And generally in the practice setting, it was a good one because if I'm dealing with a new metal, a metal I don't know, a special one or whatever, I think it's good to do all the tests and the procedure that was done in this practice to get to know the material as much as possible.